criteria for congruence of triangles. Let us now apply these results to study some properties related to a triangle whose two sides are equal. Do you remember what an isosceles triangle is? Well, a triangle in which two sides are equal is called an isosceles triangle. We will now prove a very important theorem of isosceles triangles. The theorem states that angles opposite to equal sides of an isosceles triangle are equal. Let us now try to prove this theorem. We are given an isosceles triangle ABC in which AB is equals to AC. We need to prove that angle B is equals to angle C. Let us draw the bisector of angle A and let D be the point of intersection of this bisector of angle A and BC. In triangle BAD and triangle CAD, we are given that AB is equals to AC. By construction, we have angle BAD is equals to angle CAD. And AD is equals to AD as it is common to both. So, triangle BAD is congruent to triangle CAD by SAS rule. So, angle ABD is equals to angle ACD by corresponding parts of congruent triangle. So, angle B is equals to angle C. Do you think the converse is true? That is, do you think that the sides opposite to equal angles of a triangle are equal? Well, it is. This gives rise to another theorem. The theorem states that the sides opposite to equal angles of a triangle are equal. In triangle ABC, the bisector AD of angle A is perpendicular to side BC. Show that AB is equals to AC and triangle ABC is isosceles. In triangle ABD and triangle ACD, it is given that angle BAD is equals to angle CAD. AD is equals to AD as it is common to both. It is given that angle ADB is equals to angle ADC is equals to 90 degree. So, triangle ABD is congruent to triangle ACD by ASA rule. So, AB is equals to AC by corresponding parts of congruous triangle. Or, triangle ABC is an isosceles triangle. You may wonder whether equality of three sides of one triangle to three sides of another triangle is enough for congruence of the two triangles. Let us construct two triangles with sides 4 cm, 3.5 cm and 4.5 cm. Let us adjust them and place them on each other. What do you observe? They cover each other completely if the equal sides are placed on each other, so the triangles are congruent. If you do this exercise with any two triangles of equal sides, then you get the two triangles to be congruent. Thus, we come to a conclusion that triangles of equal sides are congruent. This gives rise to another criterion called the SSS congruence rule. This rule states that if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. We also have another criterion for the congruency of triangles. It is called the RHS congruence rule. Well, this congruence rule states that if in two right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. Note that RHS stands for right angle hypotenuse side. Let us look at a question now. P is a point equidistant from two lines L and M intersecting at point A. Show that line AP bisects the angle between them. We now try to solve this question. We are given that lines L and M intersect each other at A. Let P be perpendicular to L and PC perpendicular to M. It is given that PB is equals to PC. We are to show that angle PAB is equals to angle PAC. Let us consider triangle PAB and triangle PAC. In these two triangles, it is given that PB is equals to PC. It is also given that angle PBA is equals to angle PCA, which is equals to 90 degree. Now PA is equals to PA as it is common to both. So triangle PAB is congruent to triangle PAC using RHS rule. So angle PAB is equals to angle PAC by corresponding parts of congruous triangles. Till now, we have been talking about the equality of sides and angles. However, do you think there is a need to talk about unequal things? Well, yes. This is because at times we need to compare two things. For example, line L is longer as compared to line M. Do you think there is any relation between unequal sides and unequal angles of a triangle? For this, let us perform an activity. Let us fix 2 points on a drawing board, say at B and C, and tie a thread to mark a side BC of a triangle. We then fix one end of another thread at point C and tie a pencil at the other free end. Let us mark a point A with the pencil and draw triangle ABC. Now, we shut the pencil and mark another point A dash on CA beyond A. This gives the pencil a new position. So comparing the lengths of A dash C and AC, we get A dash C is greater than AC. Join A dash to B and complete the triangle A dash BC. What can you say about angle A dash BC and angle ABC? Can you compare them? What do you observe? Clearly, angle A dash BC is greater than angle ABC. Let us continue to mark more points in extended CA and draw the triangles with the side BC and the points marked. You can observe that as the length of the side AC is increased by taking different positions of A, the angle opposite to it, that is angle B, also increases. This makes us arrive at a very important result of inequalities in a triangle. The theorem states, if two sides of a triangle are unequal, the angle opposite to the longer side is larger or greater. In triangle ABC, we are given AC is greater than AB. What do we have to prove? Well, we have to prove that angle ABC is greater than angle BCA. Let us now take a point D on AC such that AD is equals to AB. After this, let us join B and D. By construction, we have AD is equals to AB. Since angles opposite to equal sides are equal, therefore angle ABD is equals to angle BDA. Angle BDA is an exterior angle of triangle BCD. An exterior angle is greater than each of the interior opposite angle. Therefore, we have angle BDA is greater than angle BCD. Thus, we can say that angle ABD is greater than angle BCD. Since angle ABD is a part of angle ABC, we can say that angle ABC is greater than angle ABD. Hence, we can conclude that angle ABC is greater than angle BCD and angle ABC is greater than angle BCA. It is important to remember that the converse of this theorem is also true. In triangle ABC, angle B is greater than angle C. We need to prove AC is greater than AB. We know that for two real numbers A and B, either A is less than B, A greater than B, or A is equals to B. Thus, from this we get that if AC is not greater than AB, then AC is equals to AB or AC is less than AB. Now, if AC is equals to AB, we know that the angles opposite to equal sides are equal. Therefore, angle B is equals to angle C, which is not true, as angle B is greater than angle C. Now, if AC is less than AB, we know that the greater side has greater angle opposite to it. Therefore, angle B is less than angle C, which is not true, as angle B is greater than angle C. Now, we have one more theorem. The theorem states the sum of any two sides of a triangle is greater than the third side. In triangle, let us observe that the side BA of triangle ABC has been produced to a point D such that AD is equals to AC. To prove BA plus AC greater than BC. By construction, AD is equals to AC, and because angles opposite to equal sides are equal, therefore angle ACD is equals to angle ADC. Angle BCD is greater than angle ACD since a whole is greater than a part. Thus, we get angle BCD is greater than angle ADC. Since greater angles have the greater side opposite to them, therefore BD is greater than BC. Now we know BAD is a straight line and BD is equals to BA plus AD. Therefore, BA plus AD is greater than BC since AD is equals to AC. Therefore, BA plus AC is greater than BC. With this, we have come to the end of this chapter. Go through the video again and familiarize yourself with the concepts and formulas you find difficult. And also check out the games and quizzes we have in store for you. Till the next session, goodbye.